Good morning students. Today we will learn about chapter trigonometry. The word trigonometry consists of two words, trigon and metry. The trigon is a type of polygon which consists of three sides, and metry means the measurement related to that polygon. So generally in class 10th we will be restricted to the triangle which is right angle triangle. So we will learn about the relationship between the sides and the angles of that triangle. So we will start with some of the important terms which generally used in trigonometry. These are sine, cosine, tangent, cosecant, secant, and cotangent. In short, this is termed as sine theta, where theta is the angle. This is a function, trigonometric function. Sine is a trigonometric function and theta is the variable which is measured in angle. So in short, sine is written as sine theta and cosine is written as cos theta. Tangent theta is written as tan theta. Cosecant is written as cosec theta. Secant theta is written as sec theta, and cotangent is written as cot theta. Now we will understand about all of this function in deep. Let's start. First of all, this all trigonometric function, we will deal with the right angle triangle in this chapter. So here is one right angle triangle. Let it be ABC, where angle B is 90 degree. You have to take any one of this angle as theta. Now the sine theta, the function sine theta will be equal to opposite side upon hypotenuse. So it is equal to, here the opposite side means the side which is just opposite to theta, that is AB, and hypotenuse is the side which is opposite to 90 degree, so it is AC. Now cos theta is equal to adjacent side upon hypotenuse. Here also the adjacent side will be a side which is adjacent to theta. So except this hypotenuse, you have to take the other side, that is BC, and the hypotenuse is AC. So this is equal to BC upon AC. Next is our tan theta. Tan theta is equal to opposite side upon adjacent side, which is equal to AB upon BC. You can also see that if I divide sine theta by cos theta, then the value you will obtain is AB upon AC divided by BC upon AC. So it will be equal to AB upon AC multiplied by AC upon BC. If you solve this you will get AB upon BC. So this is the same result you have obtained here. So this is actually equal to tan theta. So we can say that tan theta is also equal to sin theta upon cos theta. So this is one of the relationship between the sin theta, tan theta and cos theta. Our next trigonometric function is cosec theta. This is equal to hypotenuse upon opposite side. So it will be equal to AC upon AB, and we can see that this is the inverse of sin theta, because sin theta was AB upon AC. So you can write this as also as 1 upon sin theta. So you can say cosec theta is the inverse of sin theta. Now sec theta is equal to hypotenuse upon adjacent side. So here hypotenuse is actually AC and adjacent side is BC. If you observe cos theta and this one, you will see that it is the opposite of cos theta. So you can write this as 1 upon cos theta. So the sec theta and cos theta are inverse of each other. So you can write sec theta is equal to 1 upon cos theta, or cos theta equal to 1 upon sec theta. Next is our cot theta. So cot theta is written as adjacent side upon opposite side, which is equal to BC upon AB. If you observe tan theta was just opposite of this, so you can write this is equal to 1 upon tan theta. So here you observe that cot theta and tan theta are inverse of each other. So we can see that the inverse functions like this: sin theta is equal to 1 upon cosec theta, or cosec theta equal to 1 upon sin theta. Similarly, cos theta equal to 1 upon sec theta, or sec theta equal to 1 upon cos theta, and tan theta equal to 1 upon cot theta, or cot theta equal to 1 upon tan theta. Now we will use some shortcut to learn this formula here. For this we will symbolize some of the side like this. Let this be P, the angle opposite to theta be P, and the angle adjacent to this theta, let it be B, and the side opposite to angle theta BP, side adjacent to angle theta BB, and the side which is opposite to 90 degree, that is hypotenuse, let it be H. So in total all of this trigonometric function can be memorized like this. If you make a table like this, P H P upon H, B upon H, and P upon B. So if you want to memorize this function, there is a small trick to memorize it. You can memorize it like this: Pandit Badri Prasad Har Har Bole. So in this way you will memorize this formula easily and you can apply in your questions. Similarly, we can see the sine theta is P upon H, that is opposite side upon hypotenuse. The opposite of this was cosec theta. So how to read this cosec theta? Cosec theta will be read like this. From here you will read H upon P. And the opposite of this is sec theta. So H upon B. And opposite of tan theta was cot theta. So cot theta will be read as B upon H. In this way you can memorize all of these formulas, which are very important for your starting questions which are related to finding sides of the right angle triangle. Let us see one of the examples to find out the values. Suppose there is a triangle. Here it is 3 and 4 unit. So this triangle is A, B, C with this as 90 degree. Now you have to find all the trigonometric function: sine theta, cos theta, then tan theta, sec theta, cosec theta, and cot theta. So this is given triangle in which one of the side is 3 unit, second side is 4 unit, and you have to find all the trigonometric function. Now because it is a right angle triangle, we can easily find AC by applying Pythagoras theorem in this right angle triangle. So AC square equal to AB square plus BC square. So what you will get here, AC square equal to AB square means 3 chi square and BC square is 4 chi square. So this is 9 plus 16, which is equal to 25. So here AC will be square root of 25, which is 5. So you can write this as 5 unit. Now what will be the sine theta? As by the table you can memorize, it was P upon H, and P was this one, the opposite side of the here let the theta be this side. Okay, or let us find this, rather we should find like this. We have to find sin C, cos C, tan C, sec C, cosec C, and cot C. So according to C is the angle theta, and according to this angle the opposite side is AB. So AB will be the P, this will be the H, and this will be the B if you want to calculate sin C. So sin C equal to P upon H, that is equal to 3 upon 5. So what is cos C? Cos C is adjacent side upon hypotenuse, and or you can say B upon H. So B upon H, which is equal to 4 upon 5. This is the answer for this. Now tan C will be equal to P upon B. So P here is 3 and B is 4. So now we have to calculate sec C. Sec C is just opposite of cos C. So we can write 5 upon 4, the opposite of this, inverse of this value. Cosec C is the inverse of sin C. So we can write 5 upon 3. Cot C is the inverse of tan C. So we can write 4 upon 3. In this way, you can calculate all of the trigonometric ratio very easily. Our next question is to find sin A, cos A, tan A, then cosec A, sec A, and cot A. So whether this P and D and H will be remaining there only, or they will be shifted. Now the angle is shifted here. You can see theta is here because we have to find A. So according to this, the opposite side is, this opposite side of angle A is BC. So you have to take this as P now. this will be not B, and the adjacent side to this will be this one, so it will be B, and this will be remaining H only because it is opposite to 90 degree. So what is sin A? Sin A is P upon H formula. So P here is 4 and H is 5. Cos A, this is B upon H, so 3 upon 5. Tan A, this will be P upon B, which is equal to 4 upon 3. And cosec A, it is the inverse of sin A, so it will be 4 upon 5. Or you can also write the formula like this, H upon P, which is 5 upon 4. Sec A is inverse of cos A, so H upon B, which is equal to 5 upon 3. And cot A is inverse of tan A, so it will be B upon P, which is equal to 3 upon 4. So you can see how easy it is to find all of these answers. So sometimes the question, in the question, this triangle will be not given. The question might be like this: if sin A equal to, if in triangle ABC right angle at B, sin A equal to 4 by 3, then find other four by 5, then find other trigonometric ratios. So what you have to do in such question, you know the formula of sin A. Sin A is actually opposite side, that is P upon H. So first you have to make a triangle, right angle triangle, draw a right angle triangle, then find out which side is to be considered as which unit. Here this will be a P and this will be the H, hypotenuse. So this is the hypotenuse, so it will be 5, and the angle opposite to this side, opposite to the angle A, is BC, so this will be 4. Now by Pythagoras theorem again you can find this side, and this side will be coming out as 3. Now you can, as usual you have done in your previous question, you can find out all the trigonometric ratio by these given units. So this is for now, and we will be learning in more detail in our next video. Our next topic will be about trigonometric identity.